Okay, this will just be a brief review of graphing quadratic functions. To start off, let's just talk about the basic shape that we're looking for here. We're going to be looking either for an upward-facing quadratic function or a downward-facing quadratic function. And a few observations here would be that either we have a lowest point on the graph if it's an upward-facing parabola, or we have a highest point on the graph if it's a downward-facing parabola. In either case, that point is special and it's called the vertex. So the vertex could either be the lowest point or the highest point. Another thing to notice is if I were to sketch in a vertical line right through my parabola, again regardless of whether it's facing up or facing down, that vertical line becomes what we call the axis of symmetry. That means if I were to hold a mirror on that line, you would see the reflection of the graph. So that's our axis of symmetry. And I guess that's probably it as far as just really general understanding of what we're looking for when we graph. So to get into the details, let's talk about two different methods for graphing. The first method will be using what we call the vertex form of a quadratic function. This is section 6 of our textbook when we have a graph in this form. And we're going to talk about 4 items: the vertex, the axis of symmetry, as we just mentioned, and then domain and range. You'll probably find that it's helpful to talk about these 4 values, and then you can create an XY table and come up with a graph. So very generally, when a quadratic is in this form, the vertex is actually really sitting here for us. It's going to be the opposite of the h value and the same sign as the k value. So this is called the vertex form because it's easy to pick off the vertex. If we know the vertex, the axis of symmetry is actually just the vertical line x equals to h. So there's this strong connection between the vertex and the axis. So whatever x value the vertex has is also the x value for the axis of symmetry. The domain of any quadratic is negative infinity to infinity. That's true all the time. We talked about this in class, but basically the idea is you can plug in any value for x and a y value will come out. There are no restrictions like what we've seen with rationals or radicals. We don't have any of those restrictions here. The range is dependent upon whether your graph is facing up or down. So I'm going to pop back to my other page for a second here. If you were to look at a facing up parabola, like this first case here, the range would be from that low point of the vertex all the way to infinity. If we look over here at a downward facing parabola, the range would be from negative infinity all the way up to the vertex point. So the way we know if our graph is facing up or down is dependent upon our a value. So I'm going to say this: if a is greater than 0, it means our graph is facing up. So then the range would be k to infinity. And that k is really just the y value of the vertex. In contrast to that, if a is less than 0, that means our graph is facing down. The vertex would be from negative infinity to k. So that might be a little bit confusing, but we'll look at an example to clarify. So this is the vertex form. Let's try an example here. So let's look at f of x equals x minus 2 quantity squared plus 1. And let's talk about those 4 things we just mentioned. So let's start by talking about the vertex. And for the vertex, I am going to switch the value of h. So instead of negative 2, I need positive 2. And keep the value of k. So automatically my ordered pair for the vertex is 2, 1. If that's down, the axis follows quite nicely. This is the axis of symmetry. It's just going to be x is equal to 2. That connection again is whatever the x value of the vertex is, that's the axis of symmetry value. Domain, like we mentioned, is always negative infinity to infinity, regardless of what quadratic you're working with. So negative infinity to infinity. The range is dependent upon if it's facing up or down, as well as the vertex. In class I mentioned you can wait to fill in the range until you have your graph made. That's never a problem. Some of you see it at this point, that's great. I'm going to go ahead and wait until my graph is down, and then we'll look at the range. So the next step would be to build an XY table. And a nice way to think about this is to put the vertex in the middle of your table, and then to choose an x value 1 to the left and 1 to the right of the vertex x value. So since our vertex was at 2, 1, I stepped 1 to the left to go to 1 and 1 to the right to go to 3. So that's kind of our thought process there. Now to find the y value, I actually need to plug it back into my function. So to find the y value, I'm going to plug in 1 for x back in the function, get that out, and then I'll plug in 3 for x. If I were to plug in 1 for x, I would have 1 minus 2 squared plus 1. Just order of operations there. So 1 minus 2 is negative 1. Square it and you get 1. Add 1 to it and you get 2. That's that value there. Same procedure down below for 3. So replace x with 3. 3 minus 2 squared plus 1 will also give you 2. And if you're liking the different patterns we found so far with the graphing here, here's another one. If you took a step to the left and a step to the right of your vertex, the y values should always match. And that's because these types of graphs are symmetric. So now we're ready to plot these 3 points. Make a little bit more room. So I'm going to be plotting the points 1, 2, 2, 1, and 3, 2. Just do a little graph here. So 1, 2, 3. That'll be enough. So when x is 1, y is 2. When x is 2, y is 1. When x is 3, y is 2. So we find those 3 points. That's sufficient just to get a feel for the shape of this graph. So doing our best to connect those 3 points, we get an upward facing parabola. Now that that's done, let's talk about the range. Range is the y values. So if I'm talking about the y values here, the first y value I ever touch is going to be at 1. And they will grow from there. These arrows again tell me that these values keep growing. So it will go from 1 all the way to infinity. So I went ahead and filled in my range after making the graph. You can surely do the same. And then that's it. That's all we need to do. So vertex, easy to pick off. Axis comes from the vertex. Domain is always negative infinity to infinity. Range is related still to the vertex, the y value of the vertex, and then whether that graph was facing up or down. So that's an example from section 6. Let's jump over though and look at an example now from section 7. In section 7, the general form is the standard form of a quadratic function, f of x equals ax squared plus bx plus c. The vertex here is found in a slightly different way. Other than that, the rest of the process is really the same. The way we find the vertex here involves a little bit more calculation. The x value will be found by negative b over 2a. The y value will be found just by plugging that x value back into the function. So that's the kind of funny notation for describing the vertex. Just as before, the axis will be the x value of the vertex. So in this case, negative b over 2a defines the x value of the vertex. Domain is still, of course, negative infinity to infinity. Range depends on whether it's facing up or facing down, and then also what the y value of the vertex is. So I'll just go ahead and leave that blank for now. because it's dependent upon a few factors. Okay, so let's do a specific example here. Let's take a look at f of x equals 2x squared minus 4x plus 1. We'll try this one out. And just as my first example, I'm going to go ahead and start by identifying those four values: the vertex, the axis, the domain, and the range. So to find our vertex here, we'll start with finding x by using negative b over 2a. In our example, the b value is negative 4, so negative b will really be 4. And twice our a value here looks like twice 2, which is also 4. So the x value of the vertex is 1. To find the y value, we're just going to be taking that x value we found and replacing it in the function. So y in this case will be 2 multiplied by 1 squared minus 4 times 1 plus 1. So we'll just follow our order of operations there. So 1 squared is 1, times 2 is 2, minus 4 is negative 2, plus 1 is negative 1. So our summary there is the vertex would be 1, negative 1. If that's our vertex, the axis is just x equals 1. That's again coming from the x value of the vertex. Domain we said is always negative infinity to infinity, so that's still true here. So negative infinity to infinity. And the range, you can think about it and figure it out at this step. If you like, you can make your graph and then come back to it. Just don't forget. So I'm going to go ahead and leave it, and we'll come back to it again here. So next step is build that table. I've asked for 3 values. Vertex can be the middle value. So I'm going to go ahead and put our 1, negative 1 in the center of our table. So when x is 1, y is negative 1. I'm going to back up 1 to the left and 1 to the right of that x value for the vertex. And now our job becomes finding the y value. So let's see, we'll pop back up and try plugging in 0 for x in our original function. So back here, replacing x's with zeros, it really knocks out my first term and my second term and leaves just 1. So when x is 0, y is 1. And then the other x value that we want to look at from our table is when x is 2, find y. And you could run through it by the same procedure we just talked about. Because of time, I'm going to go ahead and put what it comes out as, which is 1. And I know that because the y values on either side of the vertex better match. So let's plot those 3 points, then we'll come back to our range. So 0, 1, and 1, negative 1, and 2, 1. So 0, 1, 1, negative 1, 2, 1. Connecting those points, we'll get that U shape we've been talking about. And our range in this example would be our smallest y value, which will be at negative 1, and it will grow to infinity because our graph continues indefinitely in that positive direction. So there's just another example of graphing. This one was a section 7 example. Our first was section 6. The main difference between these two methods is in how we find the vertex. So hopefully that helps as you work with the graphing.